Science A, Unit 2, Lesson 5, String Objects. This lesson has quite a few objectives, but they are all kind of tied together. You're going to learn the difference between primitive and class data types and how Java stores these in the computer memory. You'll understand the effect that this has when declaring new strings, and use the keyword null to indicate an empty class data variable. You should, at the end of this, understand that the plus operator causes strings to be concatenated and integers to be added, and therefore data type matters. Understand the purpose of escape characters in strings and write programs using several different escape characters. There are two kinds of data types in Java: primitive data types and class data types, also called reference data types. An easy way to tell them apart is that class data types are capitalized and primitive data types are not. Primitive data types only hold one piece of data at a time. Int and double are both primitive data types. They each hold one number at a time. When we declare a primitive data type, Java allocates space in memory and stores the data there in the space as the information that tells us what the variable is. Here's an example with some pictures. Primitive data and class data. Notice the primitive data type int, lowercase I, int, where string is capital S and then string. You declare an int as int, x is set to 5. And when you reference x, x is 5. It's just 5. Int y equals x and y is 5. Now, if I'm declaring a string, instead of a actually equaling hello, a equals a place in memory that points to the string hello. Now you can declare a string as a is set to double quote hello, and it automatically does the new string. A less common way of doing it is less common is set to new string. This says go out there and create a new string and make it hello. Both of these do the same thing. Here, notice we get A and we get B. For strings, knowing what is going on in memory doesn't make much difference to us because the string class is what we call immutable. This means once we set up a string in memory, we can't actually change it. All we can do is make the variable point at a different location in memory. Other mutable class data types allow us to actually change what's stored in the memory location. If A and B point to the same object, changes to that object will be reflected in both variables. So in other words, if instead of A and B up here, both pointing to separate strings with hello, if instead this pointed up here and I changed hello, then B would also change. Okay? And we'll talk about that a little bit later, how that happens. But right now, these are immutable. String alpha is set to Harry Potter. String beta is set to alpha. Alpha is set to alpha plus and the goblet of fire. System.out.println alpha, system.out.println beta. In line 1, okay, to understand what's happening, in line 1, alpha is set to a memory location which points to the string Harry Potter. Then beta gets the same value that's in alpha, but it's set to a different memory location. Alpha is set to alpha concatenated with and the goblet of fire. So it breaks this. It's no longer pointing to this spot in memory. It points to a new spot, and it's got the concatenated string. So then when you system.out.println alpha, it's going to output Harry and the goblet of fire. Beta is still just outputting Harry Potter. Variables of class data types do not always have to hold a memory location all the time. Sometimes they can be empty. We call a class variable which contains no data null. We can actually explicitly set a class variable to be null. String example. We're just saying we're going to have this string. It's going to be an example. It doesn't have a value yet, so don't store it anywhere. Just know it's coming. String other example is set to null. Again, there's another example. We're going to get this other example. Doesn't have a value yet. Concatenation. String addition is called concatenation, and all it does is glue two strings together. We can also use the plus equals operator to add on to a string we have already created. However, this is actually creating a new string reference because strings cannot be edited. So, in the example below, H is now referencing a new string with the combined string hello world. So we had hello, and then we concatenated world onto it. We didn't really put the strings together. We made a whole new one with the two added together. What we need to be aware of is that if Java is already dealing with strings, then it will take any primitive value, example an int or a double it finds, and implicitly convert it to a string. So if I want to concatenate or write out the sum is, if I do the sum is, concatenate it with x plus y, I'm going to get the sum is 53 because Java sees a string and is going to promote these int values to strings and then concatenate them. So you're not going to get 8, you're going to get 53. Probably not what you wanted. This happens because of the way Java allocates memory. Once it starts working with strings, it continues to look at things as strings and interprets the plus symbol as a concatenation operation. If you want to actually output what the sum is, we can circumvent this using the advantage of order of operations. Notice right here, we use parentheses. We have concatenate paren x plus y close paren. Order of operations says do this first. Well, x and y are both ints, so this plus, because it's inside the parentheses, now means add. Then you're moving outside the parens, and we have a string, so this plus is still going to mean concatenate, and we're going to get the sum is 8. Escape sequences. Since Java uses quotation marks to indicate that something is a string, we need to use an escape sequence to indicate to Java when we want to actually print a quotation mark. I want to print quotation marks out in my output. Well, that's hard. There are many escape sequences that tell Java how to handle special cases. All escape sequences start with a backslash. The backslash on your computer is just above the enter. So it's on the right-hand side of your keyboard, just above enter. So to include a literal quote in a string, you would do backslash and then the double quote, and that would actually put the double quote out there. To include a new line, backslash n. To include a tab, backslash t. If you wanted a single quote, backslash single quote. To include a literal backslash, you do backslash backslash. Okay, remember, comments are forward slashes. Backslash is the escape sequence, starts the escape sequence. So here, system.out.print, hello world, new line, tab, your computer. Would output hello world with the new line because of the backslash n, and then it would tab in whatever the tab is set to on your computer, your computer. Very useful. You don't have to always, you don't necessarily need to memorize all of them. You do need to know the backslash is the escape character. That starts it. That's how you get a double quote in. And then, as I said, the ones that are really important are backslash n for new line and backslash t for tab. The others are just, I want this to print, I want the double quote to print, I want the single quote to print, I want the backslash to print. We can include comments in code which will not compile or run. Comments can be useful for leaving ourselves a to-do list or for isolating a problem while debugging. To mark one line of code as a comment, we use 2 forward slashes. And by the way, comments are extremely important. They're important for the people who are going to come along and support the code, modify the code. If you move on to another job, they may have to debug your code. // this is a comment. Now, what happens if I want a big block of code? I've got a lot of information. Well, in that case, to mark a block of code as a comment, we use /* to begin the block and */ to end it. So if I have multiple lines, I can put everything after this starts as a comment. All comments from here to here, and then this ends it. There are a lot of times, if you have a programming job, where your employer will have a particular way to comment code that identifies the programmer, the group responsible, the date it was created, tested, updated, etc. Because all of that would be on multiple lines, you don't want to squish it all on one line, and there's usually some format to it, you would use this kind of block commenting. This concludes Lesson 5.